This is section 3.2, quadratic functions. So we've been talking about different types of functions in the previous chapter. We talked about linear functions, and in chapter 1, we talked about functions in general. So now we're going to be very into just different types of functions. So we did linear functions, and now we're going to do quadratic functions, and then we're going to do polynomial functions. So let's start off with a general polynomial function. So when we talk about polynomial functions, typically what we do is these guys have degree n. So you have something that looks like this. So maybe you have a polynomial p of x or f of x or whatever, and it looks like this: a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a1x plus a0. Okay, here an is not equal to 0. Okay, so what this basically means is that you have some sort of polynomial of degree n. Here n is a positive or a non-zero or non-negative integer. So it's a positive number, okay? So this is a polynomial. So polynomials you probably have seen like x cubed plus 2x, x to the 100th power minus 3, right? X to the 3/2 would not be a polynomial because 3/2 is not an integer. Okay, so that would not be considered a polynomial. So the first type of polynomial that we're going to talk about is the quadratic. So again, this is also going to be reviewed for many of you. So feel free to skip this video if you want to, or you can skim through it. So here are quadratic functions. Now a quadratic function looks like this. So f of x is equal to ax squared plus bx plus c. And in this case, a cannot be equal to 0. So think about this. This is a quadratic function. A quadratic function has a degree of 2. Now, this is what usually we call the general form of a quadratic function. What we have seen already is actually a different form of the quadratic function. We've seen this guy. Something that looks like this. So this looks a lot like a transformation, okay? And remember that the way that we transform this is we work from the inside out. So we move h units, multiply by a, and then move everything up or down by k. Now we're using different values as opposed to what we did before, but this is basically what you want to do. Or this is basically what the quadratic kind of looks like in a different form. This form, what we call is standard form. It's also called vertex form. Okay, so we have standard or vertex form. So this guy, our goal kind of is to kind of make it in this form because we know how to graph guys that look like that. This one's a little hard. Doing this one might be a little difficult to graph immediately. Okay, now we kind of already know what a quadratic function looks like. We know that a quadratic function has the following graph. So it kind of looks like this, and we've kind of already seen it. So it can look like this, or it can look like this. Okay, so this is what we call a parabola. This is what we call an upward parabola. This is what we call a downward parabola. Or what I like to say, a happy parabola and a sad parabola. Now, there's a couple of things that we want to address with the parabola. This lowest point is what we call the vertex. And here what we have is a minimum, is the lowest value of the quadratic function. So if this is a minimum on this other guy, this is going to be still a vertex, but it's a maximum. Okay. Now notice a couple of characteristics of the parabola. It is symmetrical, okay? So you kind of have, if I were to have like a mirror here, you can see that if I fold the parabola, you're going to have a mirror image here. This little line that I just drew is what we call the axis of symmetry. So I'm just writing down axis of symmetry. Okay. Now, where is this vertex located? Well, this vertex is actually going to be located at this particular point, HK. So this point right here is actually the point H, K and H, K. Okay. So that's basically where the vertex is. The axis of symmetry, if you see, the axis of symmetry depends on the x value. So x equals h is the axis of symmetry. X equals h. Okay. Now, what determines if you have a happy parabola or a sad parabola? Well, the a value is what determines it. If a is positive, you're going to have a happy parabola. If a is negative, you're going to have a sad parabola. So think about it as being flipped. And then one last thing, you have these guys right here that are going into the x-axis. These are what we call the X intercepts. So this guy and this guy, we call it the X intercepts. Now, sometimes a parabola may have an X intercept, sometimes they may not. So if you kind of have like a parabola floating in the sky, notice that it's not touching the x-axis at all. So this one will have no X intercepts. Okay, so that can occur. Okay, so just a couple of things about these parabolas. Now let's just remind ourselves of how to graph a parabola. So, so let's say you want to graph the following. Okay, so and what we want to do is find the x-intercepts, the y-intercepts, the domain, and the range. Let's just talk about the axis of symmetry. And let's also graph, obviously, even though I wrote it up there. Now, one way that we can graph this parabola is we can first try to locate the vertex. Now that we kind of know what a vertex is. So the vertex is just going to be h, k. So h in this case is going to be whatever this number is. And we have to be sure, because if we see here, if the vertex is at h, k, basically this h is basically the opposite sign of this guy. So if this is minus h, the vertex is going to be at h. Okay, positive h. If it was a plus h, it will be at negative h. So in this case, this is negative 1, so h is going to be 1. My k is going to be this number, which is going to be 2. So the vertex is at 1, 2. Okay? All right. Now, we can easily figure out also the axis of symmetry. The axis of symmetry is just going to be x equals h. So in this case, h is just 1, so the axis of symmetry is just 1. Okay? Let's try to find the x-intercepts. So remember, the x-intercepts is when the y is equal to 0. Y, remember, is just going to be this f of x. So we're going to say 0 is equal to x minus 1 squared plus 2. So we're going to solve for x. Minus 2 to both sides. And negative 2 is equal to x minus 1 squared. I'm going to take the square roots to get rid of that square. Oh, this is just an I. We just figured out what this was. Plus or minus I square root of 2 is equal to x minus 1. And then we just solve for x by adding 1. So x equals 1 plus or minus I square root of 2. Now, notice that this are imaginary. Here, when we're graphing the parabola, we don't care about imaginary solutions. So actually, we could have just stopped when we saw a negative under the square root. So is there any x-intercepts? No. No x-intercepts. So there's none. Is there any y-intercepts? Well, remember that y-intercepts, what we're looking at is when the x is equal to 0. Okay? So we're going to have y is equal to x minus 1 squared plus 2. We're going to plug in 0 into the x. So you're going to get negative 1 squared, which gives me 1, plus 2, which gives me 3. So my x-intercept is going to be, when the x is 0, the y-intercept is going to be 3. So we're going to write it as a point, 0, 3. Okay? All right. Now, usually when we want to find the domain and the range, it's better if we just graph it. So we know where the vertex is. It's 1, 2. So let's just try to graph it. So it's at 1, 2, 1, and then 2. Here's 1 and here's 2. Here is my vertex. We have a y-intercept of 0, 3, 0, 3. Okay, so we have that. Now, what else do we know about this parabola? Well, if we look at the parabola, you can see that it's going to be a happy parabola because there's the a value in front of it is positive. So it's going to be happy. It's going to cross through there. It's going to cross over there. Now, of course, could we have used the transformations? Yeah, we could have done that as well. Okay, but here's just an alternative way to do it. Okay, so using all these different characteristics. Now here you can see that the domain is going to be from negative infinity to positive infinity. And then the range is basically where the vertex is. So the vertex is at 2 included all the way to infinity. Okay, so that's going to be the domain and the range. Okay, that basically is all of it. Yeah, so notice that there's no x-intercepts. You can kind of clearly see it here. It doesn't go through the x-axis at all. So this is a parabola in the sky. Okay, so doing problems that actually are in vertex form are super easy. They're not that difficult. What's difficult is when you want to have something that's not in vertex form. Ax squared plus bx plus c. How do you graph these guys? Okay, so what we're going to do in the next video is that we're going to talk about these, how do we convert these to vertex form.